What if I told you there's a book that has defeated the greatest code breakers in history? A book that survived the team that cracked Japan's most complex cipher in World War II. A book that even artificial intelligence cannot read. And what if I told you that this book might not even be written in code at all, but in something far more mysterious? Today, we're diving deep into why every attempt to solve the Voynich manuscript has failed, and what cutting-edge science is revealing about this 600-year-old enigma that changes everything we thought we knew. The Voynich manuscript sits in Yale University's Beinecke Rare Book Library, innocently nestled among other ancient texts. At first glance, it appears to be just another medieval book, roughly the size of a modern paperback, with about 240 pages of aged vellum. But this unassuming artifact has earned a reputation as the world's most mysterious manuscript, and for good reason. Unlike other ancient texts that have been translated and understood, the Voynich manuscript has resisted every attempt at decipherment for over a century. Today, we're not just going to tell you the story of this manuscript, we're going to explore why it continues to baffle experts, what modern scientific analysis has revealed, and why each proposed solution crumbles under scrutiny. Before we can understand why the Voynich manuscript is so difficult to solve, we need to understand what makes it unique. The manuscript is divided into 6 distinct sections, each appearing to serve a different purpose. There's a botanical section filled with illustrations of plants that don't match any known species on Earth. There's an astronomical section with circular diagrams and zodiac-like symbols. A biological section depicts numerous nude figures bathing in strange green pools connected by intricate plumbing systems. A cosmological section shows circular diagrams that might represent astronomical or astrological concepts. A pharmaceutical section illustrates what appear to be medicinal herbs. And finally, a recipes section filled with short paragraphs of text, potentially instructions or formulas. What makes these sections truly bizarre is not just their content, but the fact that they're written in a script that appears nowhere else in human history. The alphabet consists of about 20 to 30 unique characters, depending on how you count them. The writing flows naturally from left to right with clear paragraph breaks and what appears to be a consistent grammatical structure. Statistical analysis of the text reveals patterns that resemble natural language. Words repeat with frequencies similar to those found in real languages. There are common word combinations that appear throughout the manuscript. The text follows something resembling Zipf's law, a linguistic principle where the most common word in a language appears roughly twice as often as the second most common word, 3 times as often as the third most common word, and so on. But here's where things get strange. While the manuscript exhibits properties of natural language, it also displays characteristics that make linguists deeply uncomfortable. The vocabulary is surprisingly limited for a document of this length. Many words appear with unusual frequency, creating patterns that don't quite match any known language family. The text has a repetitive quality that some researchers describe as almost algorithmic. It's as if someone created a language that looks real on the surface, but breaks down under closer examination. The illustrations add another layer of mystery. The botanical drawings are detailed and carefully rendered, yet botanists cannot identify a single plant with certainty. Some researchers have suggested they might be imaginative combinations of different plant features. Others wonder if they represent extinct species or plants from regions unknown to medieval Europe. A few have even speculated they might depict extraterrestrial flora, though this theory is generally dismissed by serious scholars. The astronomical diagrams are equally puzzling. They show circular formations with what appear to be stars or celestial bodies, but they don't correspond to any known astronomical or astrological models. To truly appreciate why the Voynich manuscript remains unsolved, we need to understand who has attempted to crack it and why they failed. These weren't amateur enthusiasts or casual hobbyists. These were some of the most brilliant cryptographic minds in human history. people who had successfully broken codes that nations believed to be unbreakable. Let's start with William Friedman, a name that should command respect in any discussion of cryptography. Friedman wasn't just good at his job, he was legendary. During World War II, he led the team that cracked Japan's Purple Cipher, one of the most sophisticated encryption systems of its time. This breakthrough provided the Allies with invaluable intelligence that helped shape the course of the war. After the war, Friedman became the chief cryptologist for the newly formed National Security Agency. If there was anyone who could crack the Voynich manuscript, it should be him. Friedman approached the manuscript with the same methodical precision that had served him so well throughout his career. He assembled a team of expert cryptologists, people who had proven themselves capable of breaking the most complex codes. They called themselves the First Study Group, and they dedicated themselves to the manuscript with an intensity that bordered on obsession. For 40 decades, Friedman returned to this puzzle again and again, applying every technique in the cryptographer's toolkit. Arsenal. He looked for substitution ciphers, where each symbol in the manuscript might represent a letter in a known language. He searched for transposition patterns, where letters might have been rearranged according to a specific system. He investigated polyalphabetic ciphers, where the encryption method might change throughout the text. He even explored the possibility of steganography, where the real message might be hidden within the apparent text. But nothing worked. Every approach led to dead ends. Every pattern that seemed promising collapsed under further analysis. Eventually, Friedman reached a conclusion that must have been deeply frustrating for someone of his abilities. He suggested that the manuscript might be written in an artificial language, possibly a philosophical language created by the author. This was his way of saying that traditional cryptographic approaches were doomed to fail because the manuscript wasn't encrypted in any conventional sense. Friedman wasn't alone in his failure. The manuscript has defeated countless other experts over the years. Professional linguists have analyzed its structure and found themselves unable to place it within any known language family. Computer scientists have applied sophisticated algorithms and machine learning techniques, only to find that the patterns in the text resist classification. Even in recent years, when researchers fed the manuscript's text into advanced artificial intelligence systems trained on hundreds of languages, the AI produced nothing but nonsense. The programs could identify that the text had structure, that it followed rules, but they couldn't determine what those rules meant. What makes these failures so significant is that these same methods have succeeded elsewhere. The techniques that failed on the Voynich manuscript have successfully decoded everything from ancient linear B tablets to complex military ciphers. When tools that should work don't work, it tells us something profound about the nature of what we're dealing with. The manuscript isn't just difficult. It's difficult in a way that suggests it might operate on principles we don't yet understand. Faced with a puzzle that seems impossible to solve, many people have naturally wondered whether the Voynich manuscript might simply be an elaborate hoax. After all, if something appears to have meaning but resists all attempts to interpretation, perhaps it was designed specifically to frustrate readers while containing no actual content. This theory has particular appeal because the manuscript's discoverer, Wilfrid Voynich, was a rare book dealer who would have profited handsomely from such a mysterious artifact. The hoax hypothesis seems compelling on the surface. Voynich discovered the manuscript in 1912 at Villa Mondragone near Rome, purchasing it along with other manuscripts from a group of Jesuits who needed money. As an antiquarian book dealer, Voynich would have understood the market value of a mysterious, unreadable ancient text. He had the motive, as selling such an artifact could bring substantial profit. He had the opportunity, as he handled rare books and manuscripts professionally. And he presumably had the knowledge necessary to create something that would fool experts, at least initially. But here's where the hoax theory encounters serious problems. Modern scientific analysis has revealed details about the manuscript that would have been impossible for Voynich to fake in 1912. Let's start with the most damning evidence against the hoax theory: radiocarbon dating. In recent decades, researchers have subjected the manuscript's vellum pages to radiocarbon analysis. The results consistently place the material between 1404 and 1438. This means the animal skin used to create the pages dates to the early 15th century, over 500 years before Voynich discovered the manuscript. Now, you might argue that Voynich could have obtained blank pages from that era and written on them, but consider the practical challenges. He would have needed to find 240 sheets of pristine, unused 15th century vellum. Vellum was expensive even in its own time, made from specially prepared calfskin. The likelihood that such a large quantity of blank period vellum existed and that Voynich could have acquired it without rousing suspicion is extraordinarily low. Moreover, radiocarbon dating wasn't developed until the late 1940s, decades after Voynich's discovery. He would have had no way to know that future scientists would be able to date his materials with such precision. Why would he have gone to such extreme lengths to obtain period-appropriate materials when no one in his era could have detected modern materials? The ink and pigments present similar problems for the hoax theory. Chemical analysis has shown that the inks used in the manuscript match those typical of early 14th century Europe. The pigments used in the illustrations also correspond to materials available and commonly used during that period. Again, these are details that Voynich couldn't have known would be testable. The chemical composition of historical inks and paints wasn't well understood in 1912. Voynich would have needed to somehow intuit what future chemical analysis would reveal, and then meticulously recreate period-appropriate materials. But perhaps the most compelling evidence against the hoax theory comes from linguistic analysis. Remember those statistical properties I mentioned earlier? The way the text follows zip-flaw and exhibits other characteristics of natural language? These patterns weren't understood or documented until well after Voynich's time. A forger in 1912 wouldn't have known to include these subtle linguistic features because linguists themselves didn't know about them yet. The manuscript displays mathematical properties in its text that align with natural language formation, properties that would have required incredibly sophisticated knowledge of information theory and computational linguistics to fake. These fields didn't even exist when Voynich discovered the manuscript. There's also the historical provenance to consider. While the manuscript's early history is somewhat murky, there is documented evidence of its existence well before Voynich's discovery. Letters and records mention the manuscript in collections dating back to the 17th century. Rudolph II, Holy Roman Emperor, is believed to have owned it in the late 16th century. The signature of Jacobus de Tepanek, one of Rudolph's physicians, appears on the manuscript in ink that has faded so much it's only visible under ultraviolet light. This progressive fading is consistent with natural aging and would be extraordinarily difficult to fake convincingly. So if the manuscript isn't a hoax created by Voynich, could it be an earlier hoax created by someone else? This theory has been proposed, suggesting perhaps a 16th or 17th century charlatan created the manuscript to sell to a wealthy collector like Rudolph II. But this theory faces its own problems. Creating a document of this complexity and consistency would have required enormous effort and skill. The text alone represents thousands of carefully formed characters maintaining consistent patterns throughout. The illustrations required artistic ability and knowledge of medieval manuscript production. All of this effort for what would have been, at best, a single sale? Most historical hoaxes were much simpler affairs, designed for quick profit, not elaborate projects requiring years of dedicated work. Fascinating details that constrain the possibilities and eliminate some theories while making others more plausible. Let's start with what we've learned from examining the physical manuscript itself. Multispectral imaging allows researchers to see details invisible to the naked eye, revealing corrections, erasures, and layering in the text. These studies show that the scribe who created the manuscript was skilled and worked with confidence. There are relatively few corrections or obvious mistakes, suggesting either careful planning or extensive practice with this writing system. The consistency of the handwriting throughout most of the manuscript suggests it was primarily the work of a single individual, though some researchers have identified subtle variations that might indicate either multiple scribes or a single scribe working over an extended period during which their handwriting naturally evolved. Chemical analysis of the inks has revealed that they were applied in a specific order. The text was written first, with illustrations added later. This tells us something about the manuscript's creation process. It suggests the scribe knew in advance where illustrations would go, leaving space for them while writing. This level of planning argues against the manuscript being random gibberish hastily thrown together. It shows intentionality and organization. The botanical illustrations have been subjected to intense scrutiny by botanists and art historians. While no one has definitively identified the plants, researchers have noted that some illustrations share characteristics with known species, albeit in unusual combinations. Some researchers propose that the plants might be artistic representations meant to convey symbolic or metaphorical meanings rather than literal depictions. Others suggest they might be careful observations of real plants, rendered in an artistic style we're not accustomed to seeing. A few researchers have even wondered whether the illustrator might have been working from descriptions of plants they'd never personally seen, perhaps exotic species from distant lands described by travelers. Statistical analysis of the text continues to yield intriguing results. One consistent finding is that the manuscript's text has what researchers call a high entropy at the character level, but low entropy at the word level. In plain language, this means that the individual characters appear in relatively random patterns, but the words those characters form are much more predictable. This is the opposite of what we see in most natural languages, where words are less predictable, but the patterns of letters within words are more constrained. This unusual property might suggest that the manuscript uses a sophisticated writing system, perhaps one where characters represent syllables or concepts rather than individual sounds, or where the apparent words are actually compound units of some kind. Another fascinating discovery involves the repetitive nature of certain passages. Some sections of text contain word sequences that repeat with unusual frequency, sometimes with only minor variations. This could indicate several things. It might suggest the text is describing processes or procedures where similar steps are repeated with slight modifications. It might indicate a poetic or liturgical text where repetition serves a rhetorical or mnemonic purpose. Or it might suggest that the writing system itself has some inherent redundancy built into it. Machine learning approaches have provided mixed results. When researchers train neural networks on the manuscript's text, the networks can learn to generate text that looks statistically similar to the original. This might suggest the text follows learnable rules. However, these same networks fail to extract any meaningful structure that could lead to translation. They can mimic the surface patterns, but can't penetrate to any underlying meaning. This is precisely what we'd expect if the manuscript uses a writing system or language that operates on principles sufficiently different from those the AI was trained on. One of the most recent and controversial findings came from researchers who used artificial intelligence to analyze potential source languages. Their system suggested Hebrew as a possible base language, proposing that the manuscript might be Hebrew text written in a special encoding. However, this finding has been met with significant skepticism. The translations produced using this hypothesis have been criticized as either nonsensical or so heavily interpreted that they could support almost any theory. The Hebrew hypothesis illustrates a common problem with Voynich manuscript solutions. When researchers announce they've decoded it, their translations often require so much interpretive flexibility that they're essentially unfalsifiable. If you can make anything mean anything, you haven't really decoded anything.
After exploring the many failed attempts to solve the Voynich manuscript, you might feel frustrated. Why, after all this effort by so many brilliant minds, are we no closer to understanding this book? But perhaps that's precisely what makes it valuable. The Voynich manuscript serves as a humbling reminder that not everything yields to analysis, no matter how sophisticated our tools become. It stands as a testament to the possibility that genuine mysteries can persist even in our age of big data and artificial intelligence. In a world where it feels like everything has been explained, categorized, and understood, the manuscript reminds us that unknown territories still exist, waiting to be explored. The manuscript also challenges our assumptions about knowledge and understanding. We assume that with enough time, effort, and intelligence, any puzzle can be solved. The Voynich manuscript suggests this might not always be true. Some mysteries might be genuinely unsolvable, not because of our limitations, but because of the nature of the mystery itself. If the manuscript is written in a language known only to its creator, a language that died with them, then no amount of analysis will ever recover its meaning. We'd need external information, a key that might simply not exist. But perhaps the manuscript's greatest value lies in what it inspires. It has motivated researchers to develop new techniques in cryptography, linguistics, and computational analysis. It has sparked countless hours of creative thinking about how meaning can be encoded and transmitted. It has brought together experts from diverse fields, creating unexpected collaborations between botanists and cryptographers, between art historians and computer scientists. The manuscript may be unreadable, it's far from meaningless. As we continue into the future, new technologies will undoubtedly be applied to this ancient puzzle. Quantum computing might reveal patterns invisible to current methods. Advances in artificial intelligence might crack codes that seem impenetrable today. Or perhaps someone will stumble upon a related document, another manuscript written in the same hand or the same language that provides the crucial context we've been missing. Until then, the Voynich manuscript sits in its climate-controlled vault at Yale, silent and inscrutable, keeping its secrets. And maybe that's okay. Maybe we need mysteries that resist solution, enigmas that remind us that for all our knowledge and technology, the universe still holds wonders we cannot fully comprehend. The Voynich manuscript isn't just a book, it's a question mark written in the margins of history. And sometimes, questions are more valuable than answers. Thank you for joining me on this deep dive into one of history's most enduring mysteries. If you enjoyed this exploration of why the Voynich manuscript remains unsolved, consider subscribing for more in-depth analyses of historical puzzles and scientific mysteries. And remember, the next time someone claims they've finally decoded the manuscript, approach their solution with the same healthy skepticism that has served researchers well for a century. Because if solving the Voynich manuscript were easy, someone would have done it by now.